All right, today we're going to start a new chapter. We're going to start talking about graphing exponential functions. Graphing exponential functions will lead into logarithmic functions, but there are two types of exponential functions. There's exponential growth and exponential decay, and we will cover both of them today. They're very similar in how we go about doing them, but obviously there's a little bit of difference. So let's talk about the most basic exponential growth function, also obviously called the parent function. It's y equals b to the x. So some number to the x power, b standing for base. So an example b, y equals 2 to the x power. B does have to be greater than 1, otherwise, so that it does continue to grow. If b equals 1, it doesn't grow anywhere because it's 1 times 1 times 1, and that's always just 1. This type of graph is continuous. It is a function 1 to 1, and it is constantly increasing. The domain will always be all real numbers. The range, that is going to change depending upon some values that we're going to talk about in the next slide. But the range in this one is all non-zero numbers, so it's y is greater than 0. So the range is greater than 0. We will have something called an asymptote. The asymptote is a line that the graph cannot cross. And as of right now, that is that 0 number. Notice what I said with the range, it's 0, and the asymptote is also 0. Those two will always end up going together. And we always have this point 0, 1. Actually, these 3 points are very important. These will help us go ahead and graph our different equations as we're doing it. So we have negative 1, 1 over b, or in other words, the inverse of b. Remember, inverse is the reciprocal. We're flipping it. So negative 1, 1 over the reciprocal of b. The next point is always 0, 1. And then the third point is 1, b, which is the base, again. So we have these 3 points, and these 3 points are going to help us always do our graph. So remember those 3 combinations, negative 1, 1, 1 over b, 0, 1, and 1b. All right. Now, when we're talking about the transformations, this again is that formula that we talked about before with radicals. We're going to do the same thing now with exponentials. And as I said, this is going to keep coming back. This plus k on the outside is going to move our graph up or down. This minus h, so again, it's always backwards with the x here. Now, last time this was inside the square root, but this time it's just in the exponent, just different type of graph. So that's how we have the differences here. Notice it's minus h, so it's always backwards. So a positive, so a plus 2 here would go ahead and actually move it back left 2. A minus 4 will actually move it to the right 4. So it's kind of a little bit of a backwards because of the way that it's written there. And our a, our value in front, is again going to go ahead and expand or compress the graph depending upon its value. And a negative will go ahead and flip the graph to reflect it along the x-axis. Again, that is all the same as the last one that we had. So that should not be anything majorly different. How is this all going to help us? Well, let's start with an easier graph, a very basic one. So we want to graph this and state the domain and range. So we're going to go ahead and I'm going to ask you to do these middle 3 points. If you want to do more of them, then you're more than welcome to. But those are the middle 3 points that I talked about. It's negative 1, the reciprocal. So the reciprocal of 4 is 1/4. The middle one is always 0, 1. And the last one is 1, the base, or 1, 4. So that value there is what gives us these 2. And notice here it's squared, and there it's squared also, but obviously in the reciprocal form because of the negative exponent. So we have 1/16, 1/4, 1, 4, and 16. And we can go ahead and graph that. And if you notice that 2/16, we're not even going to get to the graph. That's why I'm not really too worried about it. They do get the negative 2 here. That is easy to go ahead and do. The domain is all reals. That's what it always is. The range comes from this plus k here at the end. The range will change when we have that plus k. There is no plus k on this one, so the range stays the same. The range is all positive numbers, so in other words, we would write it as y is greater than 0. Okay, that is also our asymptote, or our dotted line that our line does not cross. So that's why it comes down and just stays across the x-axis. Now, when we're doing these, we will tend to want to go ahead and just draw in a dotted line going across, just so that we can go ahead and take a look at that. But it goes ahead and goes through there. And our points, -1, 1/4, 0, 1, and 1, 4 are all there and help define our graph. All right, let's try another one. What about y equals 3x? So here's our points, -1, 1/3, 0, 1, and 1, 3. And our dotted line should be at 0. So we should have a dotted line going across at 0, so the graph should never cross it. So this is obviously wrong, and that one's obviously wrong. So we have these two possibilities here. And we're just looking at our points, -1, 1/3. -1, 1/3 is definitely the C value here. All right, now we actually have some movement. So we're going to start with our basic function, and then we're going to move it down 2. So here's our basic function, -1, 1/3. Because again, we're talking about our base, 0, 1, and 1, 3. And then we're going to move it down 2, so we subtract 2 from the y. So 1/3 minus 2 is -0.67. You can use a decimal at this point because we're just graphing it on a graph, so that having a decimal is fine. 1 minus 2 is -1, and 3 minus 2 is 1. Notice I did not touch the x values. And then I take these 3 points with the idea that the dotted line is now at -2, and I can graph my line. Now, if you notice down here, the dotted line is here across the bottom, and when we come down with this graph, it just goes across at that point. It does not go any further. So it does level out here. So notice the range here. Domain is still all reals. The range is y is greater than -2. That -2, because we had the down 2, that -2 here at the end, goes ahead and moves my line down and also moves my range down. So here's our point 0. Let's take the 2 over here, 0, -1, and 1, 1. If you look, we have 0, -1, and also 1, 1 on there. And we also have the -1, 2, and 2/3 down here. So we have those 3 dots. We can go ahead and kind of make our graph here accordingly. So let's try another one. Now this one is up in the exponents, so that's going to change our x value. So we're going to go right 1. Again, it's opposite. Remember, the -1 acts like a +1. So we have -1, 1/2, 0, 1, 1, 2. Again, looking at this base. So -1, the reciprocal, 0, 1, and then 1, the base. And now we're going to move it to the right 1. So we're going to add 1 to all of our x's. So it becomes 0, 1, and 2. The y values don't change on this one. Dotted line still is at 0 because there's no plus or minus on the outside. So we're going to go ahead and have those points. 0, 1/2 is here, 1, 1, and then 2, 2. And so it kind of is very slow going up. And notice the change in the axes here. We went up by 1/2 as opposed to going up by 1s. So that's the little difference here. Domain is all reals, and the range, again, because there's nothing being added on the outside here, is still just greater than 0. This should be greater than 0. The equal to should not be there. That is incorrect. All right, try another one here. So we're going to do -4. So we start with our basic one, -1, 1/2, 0, 1, and 1, 2. And then we're going to -4 on the y, so -3.5, -3, and 2, with a dotted line then at -4 since we went down 4. So this has a dotted line at 4. This one has 0. This one's -4. This one's at 0. We already know it's C just from the dotted line. But if you look at your other points, -1, 3.5 is right. 0, 3, and 1, -2 is also correct. So most assuredly it's C there. So trying another one, here's a 4. So I do -1, 1/4, and then 0, 1, and then 1, 4. Now I have 2 movements. I'm going to do a +3, so my dotted line is at 3. And I'm also going to do a +2. Remember, it's opposite. So +2 on x and my +3 on y. I did them both at the same time here. So -1 + 2 is 1, and +3 with 1/4 is 3.25. And then +2 and +3 gives me 2, 4, and then 3, 7. Dotted line at 3. So we have a dotted line at 3. This one's -3. This one's at 4. This one's at 1. We actually already know our answers here. But again, just kind of checking 1, 3 1/4, yep. 2, 4, yes, 3, and that goes to about 7. We can even use this in real world examples. They can give us a different values here. In 2006, there are 1 million or 1 billion, 200 million people working worldwide using the internet. At this time, the number of users was growing by 19.5% annually. Draw a graph showing the number of users and the growth rate between those 2 years. So our original number, our A value is our original number. That's the number on the outside is 1.021. And our rate is 0.195. So when we do that, it's one, you have to add 1 to our rate. So it's 1.195. Otherwise, it's not, if you just multiply by this, it will constantly decrease, which is, of course, not what we want. We want to increase. So 1.195 raised to the t. So the original value goes on the outside and the rate goes inside with the 1. So 1 plus or 1 minus if it's a decay, which we'll talk about in a little bit. Then we can graph that. You can go ahead and use your calculator to see this if you'd like to. You'd have to zoom out quite a bit. I'm not too worried about this graph here. All right, what is a decay function? How is it different? Notice how it looks differently. It starts high on the left and goes to low on the right. On the positive x, it's high on the negative x, and then low, 0 on the positive x. Notice the difference. My base is between 0 and 1. So we're talking mostly fractional bases here, and that will make a decay. Any number between 0 and 1, when we start multiplying, we'll go ahead and lower the values. So here I have y equals 1/5. So again, I'm using the same idea. It's -1 comma the reciprocal of the base. Well, the reciprocal of 1/5 is 5. Then 0, 1, and then 1 comma the base. In this case, just 1/5. So our numbers don't change at all. It's just because this being a fraction, it ends up looking differently. Dotted line still at 0 because we're not adding anything on the outside here. So we had 0, 1, that's still there, and we had 1 comma 1/5, and we had -1 comma 5. And we have those 3 dots, and we should be able to make our line with our dotted line here. So our domain is all reals, and our range still is that dotted line, or y is greater than 0. What about this one? We have all of it together, so let's talk about how we do this. So here's my original numbers, -1, 2, 0, 1, because I'm taking the reciprocal, so -1 reciprocal, 0, 1, and 1 the base. All right. First thing that we have to do is we have to do the multiplication here. Now, when we multiply by -4, we are only multiplying the y value. Please be aware of that. We don't multiply everything by -4. It's not an expansion. It is just multiplying the y values by -4. So it's -1 comma -8, 0 -4, and 1 -2. And then we're going to do each of these. So I'm going to do my plus 1x. You could do them in either order with the adding and subtracting. It doesn't matter. But I'm just going to do it in this order. So I'm going to add 1 to my x. So all my x values get 1 more. And then I'm going to add 2 to my y. And then adding the 2 with the y does change my dotted line. So my dotted line is at +2 and not at 0, which of course would change my range, domain, and range also. So let's go ahead and look at this one. Maybe in just a moment here. All right. So my dotted line here is here at 2. So it doesn't quite get up there because we've expanded the graph. Notice again, we're going by halves this way and then by ones this way. Really poor graph choice on that aspect, but nonetheless, that's what we have. Notice what the -4 does. It does flip it down. It's on the bottom part here. So what does that do to my range? It says my range is less than 2 now instead of being greater than. So be aware when we have a negative there, we do end up having to go less than instead of greater than. The domain, again, stays at all reals. So we have our different points here, 0, -6. So 0, -6, that's the first one there, nice. 1, -2, and 2, 0. 1, -2, and 2, 0. And we have those different dots, and we can draw that the curved line that goes across and will not cross 2. So again, this kind of will trail out like this and just stay there at 2 and never crossing that line. Please make sure we don't cross that line. That's the whole point of an asymptote. All right, something really basic here. The 1/2, just flip it over. So -1, 2, 1, 0, and then 1, 1/2. That has a, there's no plus or minus here, so we're still talking about a 0 here. This one's up at 1. This one's a growth, not a decay, and there's no negative to flip it around. So we're definitely talking about A here. How about this one here with all of them? We're going to have our original ones. It's -1 reciprocal, 0, 1, and 1 base. So 1, -1, 3, 0, 1, and 1, 1/3. Then we go ahead and multiply by the -6, and that is going to flip it. So these two are growths. We're not going to have growths. We're going to have, I'm sorry, we're not going to have them on the positive side. We're going to have them on the negative. So we're talking about A and B here. But -1, 18, 0, 6. Always have to do the multiplication first. This A value first. Then you can do either one of these. So I'm going to do plus the 2 on the X, add 2 to all my X's, and then I subtract 3 on the Y's. And I get my new points with a dotted line at -3. So I've got a dotted line going across here. 1, -21 is down here. So 1, -21 is down here, and it'll get there. 2, -9, that's about right. And 3, -4. It's a little bit off there, but is kind of where we're supposed to be. I don't know why it moved a little bit, but that's what we have there. We can also do story problems. Now this is a problem, the formula they gave us in the book, A equals 1 minus R to the T. The first one that we did was plus R to the T because we was growing. So when it's growing, it's plus. When it's a decay like this, because it says it's decreasing, we do a minus. So we're just filling in. Our original value is 14.7. That's going to go in the front. And then we're doing 1 minus the 20%. So 1 minus the 20%, or 0.80 T. And again, that's between 0 and 1, so it is decaying. And you can graph that. They're going to show you that here in just a minute. Again, I don't really care if you graph this or not. We're going to be able to use that formula, however, to estimate the pressure at an altitude of 10 miles. You can go ahead and do that by putting 10 in here and just typing that in your calculator for an answer of 1.58 pounds per square inch. All right. Any questions? You can ask me in class. Otherwise, that's all I have for you today.